Welcome back to Cosmos in a Pod Space and Astronomy series. You probably look up at the moon all the time,
Yeah.
but have you ever stopped to think about how it got there?
I know I have.
It's a truly epic origin story.
It is.
Cosmic chaos,
Oh, yeah.
violent collisions,
Definitely.
and a journey from a molten world to the thriving planet we call home.
That's right.
Buckle up, it's going to be a wild ride.
It's a story that takes us all the way back to the very beginning of our solar system.
Okay.
About 4.6 billion years ago.
Wow.
Back then.
Yeah.
Imagine a swirling disk of gas and dust,
I'm trying to picture it.
the remnants of the sun's birth.
Okay.
It's in this chaotic cloud that the seeds of Earth and the moon were sown.
So how do we go from this swirling cloud of dust to a solid planet? Doesn't sound like those two things go together very well.
It's a process called accretion,
Okay.
and it's more exciting than it sounds. Think of it like a cosmic snowball effect.
Uh-huh.
Tiny particles of dust
Yeah.
drawn together by static electricity start to clump together.
All right.
As these clumps grow, their
Yeah.
gravity increases,
Makes sense.
pulling in more and more material.
So it's a runaway train,
Exactly.
building and building until you have a planet.
And these baby planets, or protoplanets,
Right.
were forming all over the early solar system.
Got it.
One of these,
Yeah.
of course, was our own Earth,
Oh.
forming in the inner solar system where it was hot enough for rocky and metallic materials to solidify.
So Earth was basically a giant molten ball of rock and metal at this point.
It was.
But how did it get its layered structure?
Okay.
The core, mantle, and crust. We know that's important for a lot of reasons,
Definitely.
but I can never remember exactly how it happened.
That's a great question. It's all thanks to a process called differentiation.
Differentiation.
As Earth grew and continued to be bombarded by space debris,
Yeah.
it heated up even more,
Wow.
eventually becoming completely molten.
So like a giant lava lamp.
In this molten state, heavier elements like iron and nickel
Right.
sank to the center,
Makes.
forming the core.
Okay.
Meanwhile,
Yeah.
lighter elements like silicates
Got it.
rose to the surface,
Right.
forming the mantle and crust.
Oh, right.
Imagine it like a giant cosmic sorting machine.
So the heaviest stuff sinks to the bottom and the lightest stuff floats to the top,
Right.
just like oil and water,
That's a good analogy.
but on a planetary scale.
And this layering is crucial for everything from plate tectonics to the Earth's magnetic field.
Wow.
It's the foundation of the dynamic planet we live on today.
Okay, so we have Earth,
Yeah.
a molten, chaotic world,
Yeah.
constantly being bombarded by meteors.
Uh-huh.
Definitely not the place to go for a weekend getaway.
Probably not.
But what about the moon?
Right.
Where does it fit into this story of fire and brimstone?
The moon. Its formation is one of the most dramatic chapters in Earth's early history. The leading theory, and it's a good one, is the giant impact hypothesis,
Okay.
which suggests that the moon was born from a colossal collision.
Okay, you've got to give me more details on that one.
All right.
Because a colossal collision sounds pretty intense.
Picture this. A Mars-sized protoplanet,
Okay.
which scientists have named Theia,
Yeah.
slams into Earth at an incredible speed.
Oh, well.
We're talking about an impact so powerful
Well.
that it vaporizes a good chunk of Earth's mantle and a significant portion of Theia itself.
That's absolutely mind-blowing.
Yeah, it is.
So what happened to all that vaporized rock and debris from this epic cosmic crash? I can't even imagine.
It formed a massive superheated disk of debris orbiting the Earth over millions of years.
Wow.
This debris, drawn together by gravity, cooled and coalesced to form, you guessed it, the moon.
So the moon is like a giant space scar from this ancient planetary fender bender.
You could say that.
That's incredible. But is there any actual evidence to support this theory? I mean, it sounds like something out of a science fiction movie.
There's actually quite a bit of evidence. First, lunar rocks brought back from the Apollo missions have a chemical composition that's strikingly similar to Earth's mantle,
Right.
suggesting they have a shared origin.
So they're like cosmic siblings,
Exactly.
made from the same stardust but living different lives.
Second,
Okay.
the moon is surprisingly lacking in volatile elements.
Volatile element.
Things that evaporate easily at relatively low temperatures.
Got it.
This makes perfect sense if it formed from material that was superheated during a massive impact.
Makes sense.
All those volatile elements would have been blasted off into space.
Like the impact flash baked the moon,
Right.
leaving behind a very specific set of ingredients.
Exactly.
I never thought about it that way.
Is there any other evidence that supports the giant impact theory?
Is there?
Think about our seasons, which are caused by the Earth's tilt on its axis.
Uh-huh.
That tilt,
Yeah.
that 23.5-degree angle,
Right.
is likely a direct result of the giant impact.
Yeah.
The collision would have knocked Earth off kilter,
Well,
giving it the tilt we know today.
so the moon's birth not only shaped our planet physically,
Yeah.
but also gave us the seasons,
Right.
and as a result, our climate.
It's a pretty amazing chain of events.
Yeah, it is.
And we're only just starting to understand all the ways the moon has shaped the Earth.
Okay.
What's fascinating to me
Yeah.
is that the early Earth-Moon system
Uh-huh.
would have looked vastly different from what we see today.
Okay, I'm definitely intrigued by this.
All right.
Paint me a picture of this early Earth-Moon relationship.
Imagine a much larger moon.
Okay, a larger moon.
A massive glowing orb dominating the night sky.
Wow.
Remember, it was
Yeah.
much closer to Earth back then.
Right.
And because of that proximity,
Okay.
the gravitational pull between them was much stronger, generating much stronger tidal forces on Earth.
You're talking about mega tsunamis.
You got it.
Way bigger than anything we see today, right?
Yeah.
I can imagine all that extra gravity causing some seriously extreme tides.
Those incredible tidal forces also influenced Earth's rotation,
Hmm.
slowly but surely putting the brakes on how fast it spins.
Okay.
In fact, those tidal interactions still happen today
They do.
and are pushing the moon further away from Earth,
Really?
albeit very, very slowly.
So the moon is slowly drifting away from us
Biz.
a little bit every year.
That's right.
What a bittersweet thought. But I guess all good things must change,
That's true.
even on a cosmic scale.
This raises an important question for me.
Yeah.
What role did the moon play in making Earth habitable in the first place?
Yeah, that's a good question.
It sounds like it did a lot more than just cause tides.
That's an excellent question.
Oh.
We know that the moon played a crucial role in stabilizing Earth's axial tilt.
Right.
And that stability is really important.
It is.
Without the moon's influence,
Yeah.
Earth's tilt would fluctuate wildly, causing extreme and unpredictable climate swings.
Exactly.
So we're talking ice ages popping up randomly,
Right.
tropical heat waves in the Arctic, basically,
Yeah.
climate chaos. I can see how that would make it pretty hard for life to get a foothold.
It's very likely that complex life,
Yeah.
as we know it, could
Yeah.
never have evolved under those conditions.
That makes sense.
So the moon wasn't just a pretty face in the night sky.
Yeah.
It acted as our planet's silent guardian,
Like that.
keeping our climate stable and allowing life to thrive.
It really makes you appreciate all the things the moon does for us.
Yeah, it does.
And to think, all that came from a giant cosmic collision billions of years ago.
It's pretty remarkable.
But even after the moon's formation,
Uh-huh.
Earth was still a pretty wild and hostile place, right?
Oh, it was.
It wasn't exactly a paradise yet.
You're right. It was still a world in transition.
Okay.
But things were definitely starting to calm down a bit.
So things were getting better.
The constant bombardment from meteors began to ease,
Mhm.
and Earth began to cool,
Ah,
allowing its crust to solidify.
Right.
Volcanic activity became more prevalent,
yeah.
releasing gases from Earth's interior,
Right.
which helped form the first atmosphere.
So Earth was basically exhaling its first breath. And that was the beginning of the atmosphere we breathe today.
You could say that.
That's amazing.
Of course, that early atmosphere was nothing like the air we breathe today.
I can imagine.
It was a hazy mix of carbon dioxide, methane, water vapor.
Right.
Not exactly a healthy mix for us humans.
Definitely not.
But this was a crucial step in Earth's journey toward habitability.
This is such an incredible story.
It is.
But I'm sure there's a lot more to uncover about this early Earth and all the changes that happened.
There is.
It feels like we've only just scratched the surface.
You're right about that. There's so much more to explore.
Yeah.
Maybe this is a good place to pause and pick up the rest of this epic tale in part 2.
I'm already hooked.
Yeah.
Let's definitely continue this deep dive.
Sounds good to me. We'll pick up right where we left off. Welcome back to Cosmos in a Pod. Last time
Oh, yeah.
we left off with Earth finally starting to chill out a bit after the drama of the moon's formation.
Right. The cosmic dust had settled literally.
Mm-hmm.
We had a layered Earth,
Mm-hmm.
a brand new moon,
Right.
and those first oceans were starting to form.
It's really incredible.
I'm ready to hear what happened next.
This is where things get really exciting because this is when Earth starts on its path to becoming the habitable planet we know and love.
Okay, set the scene for me.
All right.
What did Earth actually look like at this point?
Imagine a world that's still pretty hot.
Hot.
Volcanoes are erupting everywhere,
Ah,
spewing out lava and gases into the atmosphere.
okay.
The sky wouldn't have been that clear blue we're used to.
I see.
It would have been a hazy mix of carbon dioxide, methane, and water vapor.
Not exactly breathable.
No, not at all.
How did we go from that toxic soup to the air we have now?
Well, one of the key players was those newly formed oceans.
Oh, the oceans.
Remember, Earth was still cooling down as
Right.
it did.
Yeah.
All that water vapor in the atmosphere started to condense
Okay.
and fell as torrential rain.
Like mega rain.
Talk about a bad hair day.
I'd say so.
This rain filled the huge basins that eventually became our oceans.
So the oceans were like giant air purifiers.
Yeah.
Sucking up some of those harmful gases from the atmosphere.
That's a great way to think about it. The oceans played a huge role in regulating what the early atmosphere was made of. They absorbed a lot of that carbon dioxide,
Okay.
which eventually got locked away in rocks and sediments.
So like they were cleaning up the atmosphere.
Yeah, in a way.
Okay, so the oceans were like a giant carbon sink,
Exactly.
pulling CO2 out of the air and cooling down the planet even more.
And all that cooling was essential for life as we know it.
Oh, ice?
As the temperatures dropped,
Yeah.
more and more of the water vapor in the atmosphere condensed, which eventually led to clearer skies and a more temperate, stable climate.
So it was starting to look like a place we could actually live.
Yeah, it was.
We're getting closer and closer to the Earth we recognize. But there's still one big piece missing. Oxygen.
Right.
Where did that come from?
Oxygen.
Yeah. The big one.
The breath of life, that's a whole other story.
Okay.
And a fascinating one.
Is it really?
See, the early atmosphere hardly had any free oxygen.
Okay.
It wasn't until photosynthetic organisms evolved billions of years later
Wow, so way later.
that oxygen levels really started to rise.
So those tiny bacteria are responsible for all the oxygen we breathe.
Yeah. You're talking about those microscopic bacteria, right?
Yeah.
They were just doing their thing for
Right.
pumping out oxygen as a byproduct.
But there's a side effect.
And completely transformed the Earth's atmosphere in the process. It's incredible how these tiny creatures made such a huge impact.
It's mind-blowing.
It is.
The very air we breathe is a result of billions of years of their hard work.
Yeah. Isn't that
It
amazing?
really makes you appreciate those little guys, doesn't it?
For sure.
Let's shift gears back to the moon for a second.
All right.
We talked about how it stabilized Earth's tilt,
Mm-hmm.
but are there any other big ways the moon affected our planet?
Oh, absolutely.
Okay, what else did it do?
The moon's influence on Earth is way more profound than most people realize.
Like what?
Its gravity is the main driver of our ocean tides.
Oh, the tides.
Which create that rhythmic ebb and flow we see along our coastlines.
Tides are definitely beautiful to look at,
They are.
but they also do so much more than that.
Yeah, that's right.
I've heard they have a huge impact on marine life and entire ecosystems.
You're right. They're not just a pretty sight.
Right.
Tides play a critical role in how nutrients get distributed,
Okay.
how ocean waters mix, and even the life cycles of tons of marine organisms.
Wow. So the moon isn't just Earth's celestial companion.
No.
It's a vital force shaping the planet's oceans and the life within them.
You could even say that the moon's influence is woven into the very fabric of life on Earth.
That's a cool way to put it.
It's pretty profound when you think about it.
And we can't forget that the moon is slowly drifting away from us.
Right.
We talked about that before.
Mm.
What kind of long-term impact will that have? I mean, is the Earth going to be okay without its moon?
That's an important question.
It is.
As the moon moves further away,
Yeah.
its gravitational pull on Earth weakens.
Okay.
It means the tides will become less pronounced,
Mhm.
and Earth's rotation will keep slowing down,
Oh, okay.
which means, you guessed it, longer days.
Longer days sound pretty good to me. More time to get things done right.
Right.
So we'll have more time to enjoy those beach sunsets,
Exactly.
even if the waves aren't as big.
It's a trade-off.
Yeah,
But it's also a powerful reminder that nothing stays the same,
that's just true.
even on a cosmic scale.
I see.
The Earth-Moon system is always changing. And it's fascinating to see how these changes have influenced our planet's past and will continue to shape its future.
The moon really has shaped so much of what we see around us.
Yeah.
Everything from our oceans to the length of our days, even the air we breathe.
It's a testament to how interconnected the universe really is.
It is.
Every single object, every event is part of a larger cosmic web, influencing and being influenced by everything around it.
It really makes you feel small, but also connected to something much bigger than yourself.
That's one of the most amazing things about studying space.
Yeah,
It gives you that sense of wonder and connection to something truly grand.
I completely agree.
Okay.
Okay, we've covered so much ground in this deep dive. The moon's dramatic birth, its influence on Earth.
Yeah.
We even talked about Earth's first breath. But I have a feeling there's more to this story.
There is. All right.
You are. There's another side to this Earth-Moon relationship, and it's a bit more, let's just say, controversial.
Okay. Now I'm really intrigued. All right.
I can't wait to hear more. Let's dive into that in part 3.
Sounds good to me.
Okay.
Stay tuned.
Welcome back to the final part of our deep dive into this incredible Earth-Moon relationship.
It's been quite the journey so far.
Last time, you hinted at a more controversial side to this story. I'm dying to know what we're getting into.
Well, even though scientists mostly agree on the basics of the moon's formation and its effect on Earth, there are some areas where opinions differ.
That makes sense.
Sometimes those differences get pretty heated.
I love a good scientific debate. Bring it on.
Okay.
What are some of these controversial areas?
One of the biggest debates revolves around the finer points of the giant impact hypothesis itself.
The giant impact hypothesis.
Remember Theia?
Theia, right?
That Mars-sized protoplanet we talked about,
Yeah.
the one that supposedly slammed into Earth.
Of course.
The
moon's famous or infamous parent.
Well, some scientists are starting to question whether Theia actually existed at all.
Hold on. Are you saying that the moon's origin story might be based on a ghost planet?
Maybe not a ghost,
Okay.
but perhaps more of a phantom.
A phantom planet.
Some of the newer models suggest that the object that hit Earth was much smaller than initially thought.
Okay. How much smaller?
It might have been closer to the size of the moon itself.
So instead of a head-on collision with a planet,
Right.
it was more of a cosmic sideswipe.
That's one possibility.
I see.
And if the impactor was smaller,
Yeah.
it might explain why we haven't found any distinct traces of Theia in the Earth-Moon system.
It's like trying to find a needle in a haystack if you don't even know what kind of needle you're looking for.
Exactly.
Okay.
And that leads to another point of contention, the composition of the moon.
Yeah, the moon's made of cheese, right?
While lunar rocks do have some things in common with Earth's mantle,
Right, we talked about that.
there are also some subtle differences.
So it's not a perfect match.
Yeah.
Like, they're from the same family,
Yeah.
but they have their own distinct personalities.
That's the idea.
Hmm.
These differences have led some scientists to come up with other theories to explain how the moon formed.
Really? So they think maybe it wasn't a giant impact after all.
They're not ready to completely give up on the giant impact,
Oh, okay.
but they're exploring other possibilities too.
Okay, spill the beans.
Yeah.
What are some of these alternative theories?
Well, one idea that's gaining some traction is that the moon might have formed from multiple smaller impacts.
Multiple impacts.
Rather than one gigantic event.
Wow.
Imagine a series of collisions over millions of years.
Oh, wow.
Each one contributing to a growing disk of debris that eventually became the moon.
So instead of one big bang,
Yeah.
it was more of a slow and steady cosmic construction project.
Exactly.
Kind of like how Earth's atmosphere formed bit by bit.
And this multiple impact idea could explain some of the differences we see in the composition of lunar rocks.
So the jury's still out on exactly how the moon came to be.
It seems that way.
But the giant impact remains the leading contender.
For now, it does.
It sounds like there's still a lot of active research happening in this area.
Absolutely. But that's the beauty of science.
It is.
It's always evolving.
Right.
New discoveries and new models can change our understanding and lead to new and exciting theories.
So we're always learning something new.
It's a journey, not a destination.
I like that.
I like that analogy.
It really is. Like a cosmic puzzle where we're slowly putting the pieces together.
Uh-huh.
And we've come a long way, but there's still more pieces to find.
Every new piece we find helps us paint a more complete picture of our solar system's history.
This has been an incredible deep dive.
It has been.
We've explored the moon's explosive birth,
It was pretty dramatic.
its influence on Earth,
Profound, really.
and even dove into some of the controversies about its origins.
Yeah, always interesting to see where opinions differ.
It's amazing to think about all the things we've learned about our celestial companion.
It's been a fantastic journey through billions of years of cosmic history.
It really has.
Full of awe, beauty, and a little bit of mystery.
The best part is that there's still so much left to explore and discover.
That's what keeps science going.
It does.
There's always something new to learn, a new question to ask.
So to all our listeners out there, keep looking up, stay curious, and never stop exploring the wonders of the cosmos.
And don't forget to subscribe to Cosmos in a Pod and check out our YouTube channel for more deep dives into the universe's mysteries. Thanks for joining us.